In this video, we're going to deal with logarithms. And so we're going to start with the laws of logarithm. Now the first law of logarithm is written as a log to the base a over m. Now you could actually use any variable of your choice. We just decided to use a and m. So if you added this to log to the base m, well, to the base a of n, that is going to be equal to log to the base a of m multiplied by n. Now we're going to try to prove or derive of this expression. Now the first thing we're going to say is let us have u to be equal to log to the base a over m. Now if you had this expression, you can actually change this expression to an indicial expression. This is a logarithmic equation. You could change it to an indicial. Now how can you do that? Now if you want to do that, you need to take the base of the initial logarithm and power it to the power of the subject, which is on the other side of the equation. And the answer is going to be equal to the subject of the initial logarithm. So this is going to be a to the power of a u that will be equal to an m. Now let us say that v is equal to log to the base a of n. Now I'm going to try to change this also into an indicial equation. So that is going to be a to the v, and that will be equal to n. Now, obviously from what you see on this side, we actually have m multiplied by n. So I need to take what I know is m and what is n and have them multiply together. So that will be a to the power of a u multiplied by a to the power of a v. Now, from the laws of indices, which we worked in the previous video. By the way, if you have not actually gone through that video, I recommend the video for you so that you would actually be able to understand everything we're trying to do in this video. Now, from here, obviously, this should be a to the u plus a v. So that is what we have. We have a m n that is equal to a to the power of a u plus a v. Now this obviously is an indicial equation. How can we change this indicial equation to a logarithmic equation? Now I think I need to re-emphasize how to change logarithms into indicial equations and also to change indicial equations to logarithmic equations. So let us say we have a to the power of a b and this is equal to c. This is an indicial equation. It is an exponential equation. Now if I want to change this from this form into a logarithmic form, I need to take the base of this stuff in the left hand side, and that will be raised to the power of a c, and the answer is going to be equal to this. So I'm going to have log to the base a of a c will be equal to a b. That is how to change it. Now if I had this, let us say I had a log to the base m of an n, and that were equal to an x. I could change this expression from this logarithmic form into its indicial form. That is by taking the m and raising it to the power of the x, and the answer would be equal to the n. So that will be m to the power of the x, and that is going to be equal to an n. So that is how to do it. Now, even if you had this, you could well change it back to this form. So hopefully you understand that. So by that, we're going to solve this one. We have mn is equal to a to the power of a u plus a v. So what I'm going to do is I'm actually going to write it this other way. So this is going to be u plus v, and here we're going to have mn. Now obviously from here I can say that we got log to the base a of mn. That is going to be equal to u plus a v. That is what we have. Now obviously from here we already know that u is equal to this stuff and v is equal to this stuff. So this is what we should have. That is going to be a log to the base a of m multiplied by n. that is equal to log to the base a of a m. That will be plus a v, which is log to the base a of an n. So this is basically how to work it. This is how to prove this equation or derive it. Now the next law of logarithm is log to the base a of m divided by n. That is going to be equal to log to the base a of m minus log to the base a of n. So we're going to try to prove these also. Now first we're going to make, let us say we're going to make p. Let p be equal to log to the base a of m. And so I'm going to change this to its initial form. So we're going to have a to the power of a p. That will be equal to an m. Now let's try to make the other one a q. So we have log to the base a of an n. That is equal to a q. And so expressing it in initial form or exponential forms, you're going to have a to the power of a q, and that will be equal to an n. Now, as you well know, we actually have an m divided by an n. So this is going to be m divided by an n. Now, m, we all know that is a to the power of a p divided by a to the power of a q. Now, from the laws of indices, which we worked in the other video, we should actually have a to the power of a p divided by a to the power of a q. And so this is actually going to get changed. I'm just going to write this here now. So we're actually going to have a p minus a q. So this is what we should have in it. So in this case, we're going to have an n, well, that is some n, divided by n. That is equal to a to the power of a p minus a q. Now this expression could be changed into its initial form. Well, it's actually already in its initial form. That should be changed to its logarithmic form. So how can we do that? How can we change this expression to its logarithmic form? So this is what we need to do. I'm going to take this base, and that will be the base for the logarithm. And that must be, in such a case, that this stuff will be the subject of the logarithm. So this is going to be m divided by an n. That will be equal to p minus a q. Now we already know what a p is. This is what we have as a p. This is what we have as a q. So we just need to replace it in that equation. So this is what we're going to have. Log to the base a of m divided by n. That is going to be equal to p, which we already know is a log to the base a of an m minus a q, which we already know that is a log to the base a of an n. So that basically will be the answer. This is how to find it. Here is the next law. If you had log to the base a of m raised to the power of n, that is going to be equal to n multiplied by log to the base a of an m. Now we're going to try to prove these also. So the first thing I'm going to do, I would actually make b to be equal to this stuff. So that is going to be equal to log to the base a of an m. Now I'm going to change this logarithmic expression and convert it to its initial form. So this would obviously be a to the power of a b. That is going to be equal to an m. So I got an m equal to a to the power of a b. Now what is going to be the next thing that I need to do? Now remember that we actually had an n from the initial expression. That was actually the power of the m. So in this case, we're going to take the power of n to both sides. So that is going to be m to the power of an n. And that is going to be a to the power of a b, all to the power of the n. And then now we're going to have m to the power of an n. And here we're going to have a to the power of a b multiplied by an n. Now, there is actually something else we can do from here. This is an initial equation. Let us try to change it to its logarithmic form. So I think I need to wipe this out. So how can we change this form into a logarithmic form? So I need to take a and have it as a base of a logarithm to the subject of m to the power of n. So that will be log to the power of an a, and that will be with the subject of this. And here we're going to have a b n, right? So that is what we have. And this is completely what we said. Because we have that, this is going to be log to the base a of m to the power of an n. And I could well rewrite this as nb. Now we already know what b is. We have designated b to be log to the base a of m. So in this case, I'm just going to change this. This will be log to the base a of m to the power of n. And this will be equal to n multiplied by b. Now b in this case is going to be log to the base a of an m. So basically this is how to work it. This is how to show that this law holds. So hopefully you understand that. Now here is another one. If you have log to the base a of an m to the power of a 1 divided by n, this is going to be rewritten as this. Multiplied by log to the base a of an m. And this could also be written as log to the base a to the power of an n. And you're going to have an m here. So this is another law you really need to bear at the back. Now here is another one. If you have log to the base a of an a, the answer will be equal to a 1. And if you had log to the base a of a 0, well, of a 1 rather, that will be equal to 0. Because if we change this into its initial form, that will clearly be correct. A to the 0th power, that will be equal to a 1. And a to the 1 will be equal to an a. So this is this and this is this. And all they are actually correct. So we're on track. Now here is another one. If you had e to the ln a, the answer is going to be equal to a. Let's try to prove this. So first off, we're going to say that let b equal e to the ln a. Now next up, I'm going to take ln. Now ln, you need to know that is actually a natural logarithm. So that will be log to the base e. That is the meaning of ln. So what I'm going to do here is take ln to the base e to both sides. Or naturally, just take ln to both sides. If you took log to the base e, that will be the same thing as taking ln to both sides. So this is what I'm going to do. You need to take ln to both sides. So this will be ln b, and on this side we're going to have ln e to the power of ln a. Now from the laws of logarithm, just the one we proved lastly, you know that this could actually go to the front. So this is going to be ln b, and this will be equal to ln a. Well, so I need to rewrite that. Multiply by ln e. Now, we know that ln is equal to log to the base e. So if we have ln e, that will be log to the base e of an e. And you know that if you had a logarithm to the same base as the subject, that should be equal to a 1. So this whole stuff should be a 1. Now you just need to bear that at the back of your mind. Ln e is always going to be equal to a 1. So we have ln b is equal to ln a. Now, you could cancel these ones out. And so that will leave you with this. Therefore, b is equal to a. Now, we already know what b is. We designated that b is equal to e to the ln a. That is what we showed over here. So this is therefore going to be equal to an a. And that is basically the reason we said this is. Therefore, from that, we can actually say that e to the m ln a, that is obviously going to be e to the ln a to the power of a m. And this is obviously going to be a to the power of a m. This will be the answer to it. Now you could go ahead and try finding it out by this method that we worked just in the previous step. Now let us go on to another one. If you had log to the base a of b, this is actually going to be equal to log to the base c of a b divided by log to the base c of an a. So we're going to try to prove this, but this is called the change of base. So the first thing you need to do is, let us try to label this one. We could label it as a u. So that is going to be u equal to log to the base a of a b. Now I'm going to change this to its initial form. That obviously is going to be a to the power of a u, and that will be equal to a b. Next up, I'm going to take logarithm to the base c of both sides, because obviously you can see from here that we have a c. So that will be log to the base c of a to the u. And this is going to be log to the base c of a b. Now here we already know that u, that could actually go to the front. So that will be u multiplied by logarithm to the base c of an a. And that will be equal to log to the base c of a b. So I'm just going to wipe it from here. Now, we want to make u the subject of the formula. So we need to divide it by its coefficient, which is actually log to the base c of an a. So this is going to be u equal to log to the base c of a b divided by this stuff, log to the base c of an a. Now we already know what u is. We said that u is equal to log to the base a of a b. So in that case, we're going to have it that this stuff, which is log to the base a of a b, is equal to log to the base c of a b divided by log to the base c of an a. So this is actually the proof for it. That is how to find it. Now here is another rule. If you have a log to the base a of a b, that could be written this way. This is going to be divided by log to the base b of an a. So let us try to prove it. Now I could say that let u be equal to log to the base a of a b. And now from here, I'm going to change this to its initial equation. So this is going to be a to the power of a u, and that will be equal to b. Next up, I'm going to take logarithm to the base b of both sides. So that will be log to the base b of a to the power of a u. And on this side, we're going to have log to the base b of a b. Now, obviously, this is going to change through to a 1. And this stuff is going to go to the front. So we should have u multiplied by log to the base b of an a. That will be equal to 1. Now, in order to get a u, I need to divide through by the coefficient of it, which is actually log to the base b. So in that case, I'm going to have a u will be equal to 1 divided by log to the base b of an a. Now, we already know that u is equal to log to the base a of a b. So we just need to replace a u with what it was originally. So that should be a log to the base a of a b. That will be equal to 1 divided by log to the base b of an a. So that basically is the proof for that one. Now here is another law. If you had log to the base a of a b, that could be written as log to the base a of a c multiplied by log to the base c of a b. So how can we prove this? Now first, let us take this stuff and express it by the method of the change of base. Now we're going to use a new base, that is base c. So this is going to be log to the base c of a b divided by log to the base of c of an a. Now this is the same thing as 1 divided by log to the base c of an a multiplied by log to the base c of a b. Now this stuff is already here, so we really don't need to worry about that. We're going to be bothered about this. Now this stuff could be expressed by the method of the interchange of the base and the subject of this logarithm. That is exactly the step or the law that we talked about just immediately before this one. So this is what I'm going to do. We know that this is going to be a 1, and this will be divided by 1 divided by log to the base a over c. Now this stuff can go up, so this is going to be log to the base of a over c. Okay, and so this is what we have here. If you have this is the same thing as this. Hopefully you remember that. So this is what I'm going to do. I know that this stuff is here, and now we're going to have a log to the base a over b, and on this side we're going to have a log to the base a over c. Now that will be multiplied by log to the base c over b, and this is basically it. That is what you got. Now here is the last one. If you have a to the log to the base b of an x, that is going to be equal to x to the log of b of an a. Now how can we prove this law? So this is how we're going to do it. First, I'm going to say that let y be equal to a to the log to the base b of an x. Then I'm going to take a logarithm to the base b of both sides. So this is going to be log to the base b of a y. That will be log to the base b of an a. And this will be to the power of a log to the base b of an x. Now from the power rule of logarithms, we know that this is the power of the subject. And that could actually go to the front over here. So this would give us log to the base b of a y, and that will be equal to log to the base b of an x multiplied by log to the base b of an a. So I just need to place this expression somewhere. So we have a log, I'm gonna write it here. I think I need to rewrite it. Log to the base b of a y is equal to log to the base b of an x multiplied by log to the base b of an a. Now, we're going to work another thing. Here we have said that y is equal to stuff which is on the left hand side. Now let us try to make z be equal to stuff on the right hand side. So if we have z equal to x to the power of a log to the base b of an a, I'm going to try to take log to the base b of both sides. So this will be log to the base b of a z, and that will be equal to log to the base b of an x, and that will be raised to the power of a log to the base b of an a. So of course this would go to the front, and that will get multiplied with this. So this will be equal to log to the base b of an a, and that is multiplied by this. That is what you got. Now we need to write it out here. So this is going to be log to the base b of a z, and that is equal to log to the base b of an a multiplied by log to the base b of an x. Now from here we can find out something is actually happening. You can find out this is also here, and we also have this to be here. So because we have that, that means this is equal to this. Okay? So since you got log to the base b of a y equal to log to the base b of a z, that means we can cancel these out. So that is going to help us find y to be equal to a z. Now we already know what y is. We call y as a to the log to the base b of an x. And that will be equal to z, which we said should be x to the log to the base b of an a. And so that is basically how to prove all these logarithmic laws. Now we're actually going to move into the calculations for questions on the logarithm. So make sure to stay tuned.